All right, well, welcome back. We're going to be learning about science today. We're focusing on graphing motion. Now, when we graph motion, we're going to be looking at two different graphs. We're looking at position versus time graph and speed versus time graph. Okay, there is also something called acceleration versus time, but we won't be looking at that because it doesn't really matter right now. But on your simulator, you'll look at how it relates to an acceleration versus time graph, but we're just going to be focusing on position versus time and speed versus time, or velocity versus time graph. So here we go. So we're looking at graphing motion in general. So for instance, if we are driving 60 miles an hour on the freeway, we're going to have a constant speed. So when we look at distance on a graph, we look at distance on the vertical, time on the horizontal. So this is our position, and this is our time. Now, this is all conceptual. I'm not going to give you actual numbers. We're just looking at, is it speeding up, is it slowing down, stuff like that, or is it just staying at a constant speed? Or is it going at a constant speed? Or if it's not even going at a constant speed at all, if it's just stopped. So let's look at a few things. So if we start at home and we walk away from home, say just we were walking away from home. So I leave and I walk away from home. Okay, over time I went this far away from home. I get to a red light. I stop at a red light because I'm not going to cross the street when there's a red light. So I'm waiting at that red light. My position has not changed. Okay, I have not been able to stop time though. Time just keeps going and going and going. If you know how to stop time, let me know because I need some more time in my life. Okay, what happens when I get to that red light? Oh, you know what? I forgot to bring my wallet. I need to go back home. So I'm going to go back home. So in this case, we have someone that walks away from home, stops, waits a while, and then walks back home. Okay, so this is what we call a position versus time graph. And the way we can find out this person's speed on a position time graph is to find out the slope. So if the slope, like this right here, okay, doesn't change, then we have a constant speed. This person was walking at a constant speed, okay, whether it's 1 mile an hour or 15 miles an hour. I don't know how fast this person walks. It doesn't matter. It's a straight line. It's a constant speed. Now, because we are going away from our starting point, we would call this a positive, okay, constant speed or constant velocity. Because they are going away from their target, so they have a positive direction, okay? Now, what happens here in the middle? We're going to change colors up. What happens here in the middle? Were they moving at all? Were they just staying still, or were they going at constant speed? Well, honestly, they were going at constant speed, and that constant speed was 0. So you can have a constant speed of 0, just like your mom or dad's car is stopped at a stoplight, waiting to go. They're going at speed, their car's on, but they're just not moving, okay? That speed is just 0. So, flat line. So, a flat line or horizontal line is a constant speed of 0. Now, what happens when I was walking home and I needed to come home? Let's go this way. I needed to come home. So, I was coming back home. So, if I said that the way from home was a positive direction, I'm coming back. Back would be in negative direction. Like your mom or dad goes reverse in the car, it's in the negative direction. So, this has a negative slope, okay? Because it's going down. It's not going up. It's going down. If it's going down, it has a negative slope. So we're going to call this a, just like this, positive constant velocity, we're going to call this a negative constant velocity. So we have a negative constant velocity, we have a positive constant velocity, and we have a constant velocity of 0. Okay? Let's see how we do on the next one. So let's try again. Let's try this. Once again, I'm not giving you values. Okay? I'm just going to write position. Position. And time. Okay? And this time, we're going to notice how the slope changes a little. Okay, we have a very interesting graph here. So, what this tells you, a very gradual slope, they're going slower. A very steep slope, they're going faster. Not so fast, negative, not so fast, very fast in the negative direction. So, remember that our horizontal line gave us a 0 speed. So it's 0 speed. Let me just, boom. 0 speed. Okay. We know that this direction is a positive speed. Okay. And then the down direction is a negative speed. So think about this one for a minute. Which ones are negative and which ones are positive? I'm going to do, or is there any of them 0? So I'm going to distinguish positive from negative in green and red. So we'll say positive is green. Okay. Those are our positive sections. And then negative, we'll do orange. Those are negative. Okay. So our positives are here and our negatives are there. So we can just do a positive, positive, and positive. We can do a negative, negative. Now, none of this has a horizontal line, so none of them are 0. Now, let's discuss each part. I'm going to label each part as a letter. So let's call this A, B, C, D, and E. So in A, since the slope is very gradual, very small hill, we have a very slow speed or velocity. So we can say A velocity is positive but small. What do we know about B's velocity? Since the slope is much steeper, okay, we're going to have a greater velocity. So B would be velocity is positive but fast, or great, or large, okay? C and A, if you notice, are very similar in their slope. So C would be similar on their statement right here. D, on the other hand, is in the negative direction, but it's not a steep negative direction. It's a gradual downhill. So in that case, we would call that a negative but small velocity. And then we have a negative and a large or great velocity. So, here we go. Let's move on to the next section, and where we're going to be looking at velocity versus time graphs. So I'm going to hold on to this graph on the next page, and we're going to map it out on a velocity time graph. Here we go. All right, same graph. Oh. Now, this is going to set up this way, and I'll show you why in a minute. So it's velocity versus time graph and position versus time graph. And we're going to transpose the information from one to the other. So I'm just going to... Okay, so we know that line's up there. We know that one lines up there. We know that one lines up there. And that one. Okay, so all I'm doing is transposing the information so that my times are equal in both graphs. So we said this is a gradual velocity. And because it's not curving, it's a constant velocity. We already talked about how a straight line is a constant velocity. So we have a constant velocity. Then we increase our velocity. Very fast velocity for that section. Then we go back down to a very small velocity. And then we end up going to a negative velocity. So all these numbers up here are positive, and all these numbers down here are negative. So I need to go below the timeline to go to a negative velocity. And I have a very steep negative velocity. Okay, so that is what our graph would look like if we transposed it in the form of, a position versus time graph and a velocity versus time graph. So that purple or that magenta is what this top graph looks like on a velocity time graph. Now, in this situation, you do not see any acceleration unless you call this acceleration, which is instantly acceleration. So the way that a position versus time graph looks on here is the slope of a position time graph gives you the value of your velocity. And then on a velocity time graph, you want to go to acceleration. The slope here gives you the value of your acceleration. So I'm going to actually walk you through the Moving Man application simulation. So we're going to see this in the Moving Man simulator. So when you go to your science folder, it should look like this. You're going to click on, obviously, Graphing Motion, where you're seeing this video. And then you're going to click on the image. The image is going to download the document. Once you download the document and open it, it's going to look like this. So we have a nice man, okay, on this meter length. Okay, we have two ends. We can actually exit out of those if we wanted to, or we can add them. It's up to us. We have the house. We have the tree. We're going to talk to this so we can see how the man is moving, depending on how we want to do it. So right now he's not moving anywhere. So I can hit the play button and it doesn't do anything, right? I can stop. I can set him at a certain distance. Say that distance is 8 meters. Okay. We can give him an initial velocity. Say we want to go this way. We can also just slide this. 3.6 meters per second in that direction. I'm also going to give him a positive acceleration. Notice my acceleration is on this side. So if he's moving this direction and my acceleration is going that direction, he's going to end up doing something very interesting. So let's watch. See what happens. He slows down and he turns around and he's going the opposite direction. Let's stop. He's back home. So a negative velocity of this direction, but a positive acceleration is going to slow his velocity down. And then we're going to get a larger velocity. What if I had zero velocity or acceleration? Okay, I want a zero acceleration. Okay, well, evidently I can't get there. Just give him 0. So I'm going to give him an initial velocity of negative 2.6. We're going to watch that one. He's just not going to stop. He's going to go 2.6, 2.6, 2.6, 2.6, 2.6. He's not going to speed up. He's not going to slow down. He's just going to go the same speed the whole way. Notice that you can actually see the vectors of these. Okay? So we can watch him, and he's going to get vectors. So say I want to go this direction. And I give him a larger, and I give him a larger acceleration. So I can see that. One. Well, he's back. Okay? So the moving man is a way to see how these three things, position, velocity, and acceleration, interact. So now that we understand how he moves with position, velocity, and acceleration, let's see how he moves on the graphs. So let's give him an initial position. Let's put him here at the tree. And let's say that his house is over there. That's where we want to go. Over to the house. Let's give him an initial velocity of 1.5 or so. Okay, we're going to go to the house. But let's hear the phone ring and let's speed it up. So let's say that he hears the phone ring, and so he's going to increase about 3 or 4 meters per second every second. So let's watch him go over there. He's going to see the phone ring, and he's going to speed up, and he's going to stop. Notice on a position time graph, we have a curve. Okay, we have a nice curve. Velocity time graph, we have a slope, and an acceleration, we have a straight line, horizontal. What happens if there's no acceleration? Let's not do an acceleration. Let's get rid of this. Let's reset all real quick. Reset, good job. So a 0 acceleration, but I want to still be at the tree. Tree home, 0 acceleration, a constant speed of 2.5. Let's see what happens. Okay, so he went home. Nice straight line, no curve. Okay, we have a nice velocity. Well, if it's a flat line, what's the slope of a flat line? 0. That's why our green line here is on the 0 mark. So I want you to practice that and figure out some information. Just play around with it. Maybe go this direction. Your position is going to go negative. Your velocity is going to drop down. You can also just kind of play around. Right? You can just goof around with him, okay? If I go to constant speed, that's what I do. And if I want to speed up, I can do that. So notice my ugly graph with it, right? This is not so bad, but when you get into the acceleration stuff, it gets crazy. So I want you to play around with it, and then I want you to do the lab. Have a good day.